Thank you for that. Just word to the wise, my name's actually Keanu. Like the movie star, but not as handsome or famous. I think the best way to start off today is to recognize what change the industry is going through over the last couple of years. I think a lot of companies, a lot of industry organizations, a lot of manufacturers have really started to take on the idea that we're building places for people, or as I like to think of it, paving places for people. So to get started, I'd like to talk a bit about what the CMAA actually does. So we pride ourselves as being a free resource. So everything that we do is for the benefit of the community, for councils, for organizations, for consultancies. We sit on several standards boards, we sit on construction codes, we commission research, so obviously the University of South Australia when it came to permeable and segmental or interlocking concrete pavement technologies. University of Newcastle when it comes to the design of thermal mass or thermal research when it comes to buildings. So obviously we can't just have places for people, we need to have places for them to live in as well. And some research of the Queensland University of Technology regarding retaining wall design. We do a lot of advocacy and policy work, so with government, with organisations like the Arbor Centre, and so on. As I said before, the CMAA's main goal is to make it easier to build in our products, whether that be bricks, blocks, or pavers. In this case, probably more suitable to pavers. How do we do that? We run awards nights. We run awards categories for landscaping. So I've met a few landscape architects here, so just a hint. There is a cash prize if you do win the category. We engage, we sponsor university presentations. We come to presentations like this. We encourage a lot of growth within the industry itself. So I'm a product of that. I'm one of the young engineers that came through as an intern and is now a pavement engineer. How do we help the industry? We write technical manuals, educational presentations, we have webinars, we have presentations on our website. We commission research, we write research papers. I recently presented at the Stormwater Conference 2021 on permeable pavement technologies. We write case studies about some interesting projects across Australia. And most importantly, we do have a free technical inquiry service. So if you have any questions regarding permeable pavements, interlocking concrete pavements, or you have questions that extend outside the realms of what I'm talking about today, please do send them through. We give everyone the utmost care to every inquiry. We take a lot of time, we take a lot of pride about what we do. Here's our members. You would have seen Brickmakers sign today and maybe met their person here today as well. Brickmakers is one of our state members and they work around in Western Australia. We do have national members that work across Australia, and all of these members do manufacture pavers. So we have Arbor Masonry who works all across Australia, as well as Austral Masonry. Boral who predominantly works in South Australia. National Masonry who works across the eastern coast. A bit about me. I'm currently a pavement engineer working with the CMAA but also on secondment with Arcadis, so I'm getting a bit of I would say major infrastructure experience to kind of push more towards these sustainable things. Other than that, I've worked on several urban planning design projects. I've worked on industrial container yards. I've worked on airports. I've worked on defence facilities. So when it comes to anything regarding segmental pavements or permeable pavements, I'm probably one of the best people to speak to. And I think what's really important to understand is there's a lot of experts in this room, and you can only really be an expert in maybe one or two things in your career. So it's really important to make those connections with those people and find an expert that can help you when you really need it. DesignPave, which is the software that I'm going to be talking about today, and I'm running a satellite session on tomorrow. DesignPave was, as Simon mentioned, a University of South Australia research project that they created for us. It is a successor to LockPave, which many people may remember. LockPave was discontinued quite a while ago, so there was a need for new software, and that's where the CMAA stepped in. And we've also created a permeable pavement section to kind of tie back in and create a holistic solution. Other than that, we have our permeable paving manual. I'm currently updating this, so stay tuned. But it's still quite a good resource. It still gives you everything you need to get started on the permeable pavement journey. Today, I'm going to speak about a little bit of introduction about what permeable pavements are, talk about tree root uplift, as well as a little bit about the software itself. I think what's really important to understand when you're working with engineers, especially pavement engineers are the interface between geotech, between drainage, between road alignments, between road furniture. They're kind of like a jack of all trades. They don't actually do much, they don't actually have much say in what's going to happen to the road. We're basically brought in at the twilight hours of the design, and we're told, look, mate, we got to put a road through here. Can you design a base that satisfies these certain requirements? So when you're dealing with a pavement engineer and you want to create a permeable pavement system, you really need to get us involved much earlier than you would normally anticipate with a generic project. A little bit about why we need permeable pavements. Everyone else probably touched on this way better than I have. Again, I'm not a hydraulics engineer, I'm not a water resources engineer, but it's no secret that we're creating an urban runoff problem. We're creating issues with our water resource networks. We're overburdening our systems, and we're tarnishing what beautiful land we do have. So it's about minimizing our impact. There's no way we could completely get rid of the impact that we have on the environment, but it's about creating ways that we minimize it. And what do urban developments do? Here's a simple table about what they actually cause and the impacts of that. So we have increased volume, which can create flooding, can create habitat loss, we can have sediment erosion, we can increase temperatures of our waterways, which is bad for natural animals, and things of the magnitude. I'm not going to go through all of them, we're quite strapped for time. Well, there goes my picture, but it was of a pervious concrete pavement. Permeable pavements, and in particular PICP, as Simon was putting it, they're quite common across the world. Australia is probably on the back foot when it comes to adopting them in society, which is quite sad, but also a reason why we're here today and why we're talking about it. But permeable pavements come in many forms. They can come in open graded porous asphalt. They can also come in no fines concrete, and obviously the permeable interlocking concrete pavements. And when we design permeable pavements, we're looking at 3 types of systems. That being a full infiltration system, a partial infiltration system, or a no infiltration system. And what, as the name suggests, a full infiltration system means just that. It's a system where all the water that enters the pavement and the base of that pavement eventually exfiltrates through the subgrade of the system. So in Perth, you're actually blessed with probably the best soils to design these systems. You're sitting on really permeable sands. Where I'm from in Sydney, we deal a lot with clays and silts, so it's not often possible to create a full infiltration system, which is, for the most part, preferable. And in these systems, you can actually omit subsurface drainage. So I know when you're installing trees, installing landscaping, subsurface drainage is a necessity. But when you use a full infiltration system, you can alleviate that concern. Partial infiltration systems, as the name suggests, when we're dealing with maybe not as good a soil as sand, but not as bad as clay, we're kind of in the middle. We're looking at using a partial infiltration system. And these systems, whilst they allow some water to enter into the subgrade of the pavement, they also allow water to exfiltrate through a drainage pipe, which connects into typical stormwater. And no infiltration systems, these systems, again, as the name suggests, don't allow any water to infiltrate into the subgrade. So why would you need a no infiltration system? Well, when you have clays, which are highly reactive, they can expand, they can contract, they can really damage the pavement. And so we install a geomembrane liner, which is what you saw in the Leppington bus depot case study example, for a different purpose. That was for water harvesting, but it serves the same function. It stops water from leaving the system and allows you to do with the water what you will. So you can either exfiltrate it into stormwater, or you could reuse it for grey water applications. It could be a bit hard to remember everything, but there is technical guidance out there in the world. I think the British Standards is probably one of the best places to start. There is no permeable pavement guidance made by the Australian Standards or Austroads or Transport for New South Wales. It's really difficult to find it. I know Adelaide does have some guidance, but again, it's quite lacking at the end of the day. So what I like to do is I like to look at international standards, places like Britain, which have major experience with permeable pavements. They've even mandated in some of their car park projects. There's a lot of guidance out there. So I'll keep referring to the British standards, but know that there's a couple of ISO standards that you can use as well as American standards. So why do we use permeable pavements? Well, permeable pavements are kind of a multifunctional system. So when we think about roads, we're thinking 30% or 40% of our suburban land is used for these road surfaces that probably could have a multifunctional purpose. And when I say probably, I mean definitely. Right? So we have 40% of our land use in a suburban area that's not being used effectively. So what we really are striving to do here at the CMAA is to change that stigma on its head. We're trying to challenge the status quo. Gone are the days where we just slap asphalt down on the ground. We're looking at producing solutions that create holistic benefits. And what you can use permeable pavements for is you can create flood control systems, but it's not always about flood control or runoff control. We're talking about water harvesting. We can improve the water, and probably the most important one for today, we're looking at reducing the impacts of tree roots. Just to quickly show you how a runoff control system works, the permeable pavement acts as a stopgap. So if you can imagine, in a typical system, the water will hit the surface of the pavement in an impermeable system and run directly into stormwater drainage. That system is quite quick, almost instantaneous, if you could imagine. However, when we're looking at a permeable pavement system, we have water entering the base, and it takes time to infiltrate that base. And as it fills up, we start to see stormwater leave the pipe if you've provided one. Otherwise, it just enters the subgrade system. So in a lot of systems, especially in Perth, you can actually eliminate all stormwater drainage for your pavement, which obviously is a big benefit when it comes to costs, and it reduces a lot of maintenance impacts. Yeah, right. Water harvesting, quite simple. You've got a below ground detention system, but you've also got an usable and functional hard stand on the top of your pavement. So in this example, and the example we have in Leppington Bus Depot, which is the case study Simon had, they created 2 permeable pavement water harvesting pits. And what they did was they repurposed that stormwater or runoff as water to clean their buses. So there's opportunities to do this in small scale, whether it be putting your rainwater tank below ground in your home, as well as more large scale projects. So you can create irrigation systems for public spaces, for car parks, for parklands. water quality, permeable pavements function similar to a sand filter that you might have in a water treatment plant, except they use gravel, so not as intensive, but definitely quite potent in what they do. They use mechanical filtration, so as water enters the pavement, the pollutants dislodge and cement themselves to the base of the material. And what you get is a cleaner effluent, which means you have less suspended solids, you have less phosphorus, you have less nitrates entering your waterways, which at the end of the day means cleaner environments. Moving on to tree root uplift. A lot of these pictures will probably seem quite familiar to you since Simon's already spoken to this, and a lot of our information and research that we have from the CMAA does come from the University of South Australia. But as Simon mentioned before, tree roots are quite smart in how they find water. They send out their little finding routes, and then once they do stumble across water, they thicken up. So when we have impermeable surfaces, we get condensation on the underside of the pavement, and that causes the tree roots to thicken towards the top of the system. And apart from the fact that tree root uplift is probably one of the more unsightly aspects of urban planning and urban design, it can be dangerous. They act as intrusions, they act as trip hazards, and they can damage and cause flooding towards subsequent areas if you modify the crossfall of that road. Additional pictures of tree root uplift. And so the CMAA wanted to see how extensive was this problem across Australia. And if you can see here, we did a consumer research survey around tree root uplift, and we've actually found that about 76% of all individuals could easily remember a certain area in their local area where they had tree root uplift issues. And of the people who were surveyed, 24% thought it was a significant amount of damage. So this isn't a niche problem that we're seeing in Australia. It's quite extensive. And if I can take a survey of 1,000 people and find 76% of people see it as an issue, then maybe there is cause for some concern. As we mentioned before, the good thing about permeable pavements is they don't have that issue of tree root uplift, or they can be used to mitigate that issue. If you have a permeable pavement system, you are directing water down towards the base of the pavement, towards the subgrade, and tree roots, as I mentioned before, are clever. They move down as well with them. And so what we see is we only have very thin roots towards the top of your pavement system, but you're getting much thicker roots toward the base. Again, before and after. So same pictures from Simon Beecham's presentation. And just quickly, the infiltration mechanisms of permeable pavements can be either through widened joints, or they can be through the porosity of the paver itself, or you could have extremely large joints where you can have grasses growing through it, or you can have gravel aggregates. Why do I specify the use of permeable pavements instead of porous concrete or pervious asphalt? The simple fact of the matter is, when you have those widened joints, they're much less liable to clogging, and when they do clog, it's much easier to do a quick maintenance task on your permeable pavements over, say, asphalt, which would require mill and resheet every 5 to 10 years. Porous concrete would need to be absolutely ripped up. So it's much easier, and that's one of the benefits of using pavers itself. It's important to have that permeable pavement base course layer. As we see here, if we don't have that base course layer, water makes its way throughout the subgrade. So roots don't have a certain direction to move. In this instance, we have that permeable base course. So what happens here is water quickly makes its way through that permeable base course. There's not much water left in there. And as you can see here, roots try and make their way towards the subgrade of that pavement. And you get, because they're outside the influence zone of the pavement, you don't get that uplift. When speccing a base course, it's important to understand that the higher the void ratio, which means the more water that that base course can control, the weaker that material will be. It's a simple trade-off. It's a bit of a value engineering exercise for us pavement engineers. But just be mindful that depending on the situation, so if you're paving around a tree, then it's fine to use a single-sized uniform aggregate. But if you're looking to permeable pave a road or a car park, then you should be looking towards more graded permeable bases, because they give a much more structural strength to it. So quick considerations to go through. No time for it. I'm quickly going to go through some case studies. And these are from Australia and across the world. So this is a case study at UC Davis, where they've absolutely perfected the use of permeable pavements around trees. So this is an example of their university campus. That road carries cars, bikes, what have you, and they've actually segregated the road system using different patterns. So you can direct individuals via the car, via walking, via cycling. So it's a nice way of like creating that urban landscape. Sydney Olympic Park, a really good example, a really early example, probably one of the first permeable pavement applications in Australia. They have 163,000 metres squared of PICP and interlocking concrete pavements. So when someone tells you it can't be done, it most certainly can be done. It's been done for more than 30 to 40 years. And they've had, through crossfalls, they allow water to enter that tree basin as well. And quickly about design pave and perm pave. As Simon mentioned, we have perm pave, which is the hydrological design component, design pave, the structural design component. And it is a simpler, much more digestible flowchart about how a design pave and perm pave works. I know the other one was scary to look at, but that one's much better and was made previously. Quick paver types, I went through them already. Subgrade types, again. Yeah. This is my presentation. Just quickly going through here. So in the software, everything's pre-built in. It's just plug and play. It's cookie cutter. So you can select your base course types. You can select how much contributing area you have, how much area you have. And we use ARR data. So this works on supply and demand characteristics for water harvesting applications. And we also have the mechanistic design application. So again, it's all automated, it's all quite simple. If you have the data, you put it in. And at the end of the day, Perm Pave, Design Pave is a combination of over 40 years of hydrological and segmental pavement design knowledge. It's the only structural and hydrological design software tailor-made for the Australian climate. And it's based on the data directly taken from the Australian Bureau of Meteorology. That's it. Thank you.